This video is for Chapter 7, video number 4, naming and writing formulas for acids. So, an acid is any compound that can donate a hydrogen ion, or H+, when it's in aqueous solution. And you might remember when we were talking about just basics of chemical reactions, we indicate if something's in aqueous solution by using the subscript AQ after it. All acids at this point are going to contain hydrogen. So it's going to be H and something else. Now, there are two types of acids. There are binary acids and ternary acids. Binary acids are made of two elements only. So only two elements. And since H has to be one of them, it's going to be H and some other element. That other element will always be a nonmetal. Now, what I want you to be able to do at the end of this video is one of the things we want you to be able to do is to name a binary acid. So the rule for naming binary acids, this is kind of a big point right here, is to always look up the stem of the nonmetal. So this, for example, if the example is HCl, the nonmetal is chlorine, and the stem would be then chlor. So you're going to say that it has a name of hydro, and then you're going to insert the stem, ic acid. So HCl would be hydrochloric acid. So we just did that first example, HCl. So I'll write the name out. HCl would be hydro. The prefix hydro always is used on binary acids. The stem is chlor from chlorine, and then you add the ending or change the ending to ic acid. So using that same process, what would H2S be called? Well, the nonmetal is S, and that is sulfur. And so we would use the prefix hydro because it's binary. And then some students will say sulfic, but it is actually, we add the extra syllable, sulfuric acid. So again, think of it this way. With a binary acid, I have to add two things. I have to add the prefix hydro and the ending ic along with the word acid. So if we do another example, H3N, N is the nonmetal, that's nitrogen. So to name it, I'm going to have hydro, and then the stem, instead of saying nitrogen, I'm going to say nitric. It came from the ending, and then acid. So those are three examples of binary acids. For binary acids, again, you have a hydro in front, the stem of the nonmetal in the middle, and then the ending ic. Now, ternary acids are named slightly differently. A ternary acid is made up of more than two elements. So it will most likely contain hydrogen and a polyatomic ion. Now you could have your pink sheet sitting out. That would be helpful for the rest of this video. If you look at naming naming the ternary acid, it will depend on what your polyatomic ion ends in. If the ending of the polyatomic ion ended in ate, something like nitrate, sulfate, chlorate, what you do is you take the stem of that polyatomic ion and you drop the ate and change it to ic. And I help students, I give them the reminder, if you ate acid, you would say ic. Okay, so ate changes to ic. If the polyatomic ion ended in ite, like sulfite, nitrite, phosphite, something like that, you still take the same stem, but this time your ending is us, O-U-S. So we'll practice a few of these with polyatomic ions. Okay? Now the formulas of these acids, you can tell, are bigger than the binary acids. All of these have polyatomic ions in them. So for a good habit to get into learning how to name these, I always go through and underline the polyatomic ion. Then look up on your pink sheet what the name of that polyatomic ion is. SO4 is called sulfate. So I'm going to take off the 8 and change it to ic. Now, most students will say sulfic, but usually the correct way of saying that is sulfuric acid. Compare that to SO3. SO3, if you look up the name of that polyatomic ion, is sulfite. So this one would be sulfurous, O-U-S, acid. Notice the difference in the endings, and the difference in the endings come from the difference in the ending of the polyatomic ion. So PO4, phosphate, would become phosphoric, but technically correct would be phosphoric acid. If you wrote phosphic, most teachers would still give you credit, but when it has a fur sound at the end, sulfuric and phosphoric, we pronounce that last syllable. Let's look up ClO4. ClO4 is called perchlorate. Perchlorate. ClO4 is perchlorate. Since it ends in 8, we're going to take the 8 off and change it to ic, perchloric acid. And on this last one, HClO2 is called chlorite. ClO2 is called chlorite. So I'm going to call this acid name, since it ended in ite, I'll change the ending to us, and that will become chlorous acid. So hopefully now you understand how to do ternary names. Now, if we want you to do this backwards and write the formulas, just know that you always are going to have an H plus, and H is always a +1. And then whatever the anion or -1 is, we'll have to just balance the charges. So let's look at this. Example is nitric acid. Now the only change to this name is ending is ic. So we know that this must be ternary. So that means it's going to contain something with nitrogen, and since it ended in ic, it will contain nitrate. It's going to contain H+1 and nitrate, which is NO3 -1. I'm just going to balance those charges. A +1 and a -1 cancel each other out, so I'm going to get HNO3 is nitric acid. Moving across to hydrobromic acid, when I see hydro, I automatically know that it's a binary acid. Binary acids only contain 2 elements. One of them has to be H+, the other one must be the single element Br, bromine. That has a -1 charge. So to write that formula would just be HBr, and that has the name hydrobromic acid. Our third example for naming, or for writing the formulas, is oxalic acid. Oxalic acid ends in ic. There's no hydro, so we know that this must be ternary. The ic ending tells us that it came from something that ended in 8, so oxalate. Oxalate is C2O4 with a -2 charge, and it has to combine with hydrogen to give us the correct, to become an acid. Now, in order to get these charges to balance, I'm going to need 2 H's for every C2O4 ion. And so that's how I write the formula for oxalic acid. Now, this is a very good example because this is one compound where you do not reduce the formula. It's an acid, and we're going to leave it alone. That's the only example that I can think of for acids where you wouldn't, where you're not going to reduce in a formula. There might be one other exception that we've covered in a video, and that would pertain to our IB students usually only. Last example for writing formulas, we see hydro again. Hydro always means that it's binary. That means it contains 2 elements, hydrogen with a +1, and since this says selenic, that means the other element must be selenium. And looking at where it lives on the periodic table, you'll see that it has a charge of -2. So the formula should be H2SE. It will take 2 H's to negate the Se. So that is the formula for hydroselenic acid, H2SE. Now our last note is that HCN, even though it has a polyatomic ion cyanide, is named like a binary acid. So ask yourself, what is binary acid? So we start with, well, hopefully you said hydro. And then cyanide, we're going to say cyanic acid. So hydrocyanic acid is the correct name for HCN. That is an exception to one of the rules. So now you hopefully know how to name and write formulas for acids, and we'll have a learning check for you to practice the next time we meet in class.